Okay, so let's look at another type that you would see, and that is one that has a quotient with radicals. So let's look at the limit as x is approaching 36. In our numerator, we have the square root of x minus, and then outside of the square root of x, then we have a minus 6. And this is all over x minus 36. So again, I could see direct substitution when we go in there and plug in 36, wherever we see an x. I can see that that's going to get me 0 over 0 again. Because the square root of 36 minus 6 all over 36 minus 36 gives us the 0 over 0. Okay, so and again, in determinant form, we have to go in and manipulate. Okay, so this is where I'm just going to kind of bring in really quickly how to rationalize. In this case, we want to rationalize the numerator. For some reason, my handwriting is not looking as good as I know I'm writing better than that. Okay, so if we want to get rid of the radical in the numerator, we're actually using the fact again that a squared minus b squared, right? This factors as a minus b times a plus b. We're going to go backwards. So normally we're trying to factor this a squared minus b squared, right? The whole point of rationalizing the numerator, or getting rid of the radicals, we know that we can get rid of a radical by squaring it. So if we can come up with the opposite sign in between, we can make these difference of squares. And so I have a minus here. And so we can rationalize the numerator or denominator, depending, by multiply the binomial, the two terms that has the radical, by its conjugate. I don't know why it's not writing very, very nice. So the conjugate is change the sign in between the two terms. So in our case, if we change that sign in between the two terms, or that would be a plus in between. And so let's bring down that limit. As x is going to 36, of the square root of x minus 6 all over the square root of x minus 36. And we're going to multiply by a fancy one. So use the conjugate to make a fancy one. Okay, so we're going to multiply top and bottom by the square root of x plus 6. Square root of x plus 6. So we're going to expand the conjugate piece, but we're not going to expand, in this case, the denominator, or when we were multiplying out the conjugates. So using this fact again, if we have a difference of squares, or two factors that are conjugates and multiplying, they're the difference of squares. So we can think of this as the square root of x quantity squared minus the other term, which is 6 quantity squared, all over, I'm going to keep it in factored form, so x minus 36, that quantity times the square root of x plus 6.
I can't see it. Can you scroll it down a little bit?
Oh, you know what, this right here, normally I could. Let me get to the next page.
Okay. And where it says the limit of x, is it gonna be 3 or is it 36?
That should be 36, thank you.
Okay.
Wondering. I'm going to try if I can select this. I don't know if that would work. Okay, so it would have the limit, oops, as x was approaching 36. And we had the square root of x minus 6 all over, what was it, x minus 36. We were multiplying top and bottom by that conjugate, what was the square root of x plus 6, all over the square root of x plus 6. And then when we distribute in the numerator, we have a difference of squares. And so we're just going to square that first term. So the square root of x quantity squared minus squaring the second term. So 6 quantity squared all over. So in this case, this is where we don't want to distribute. Let's just keep it as the factors, x minus 36 all times the square root of x plus 6.
Professor, I have a quick question.
Mm-hmm.
So you're multiplying by the conjugate because you want to get rid of that square root of 6, right? And then multiplying them together just cancels it out.
We want to get rid of that square root of x. So we don't want that radical anymore. And so squaring a square root, they basically cancel out. So I don't know if you guys remember, but square roots can be rewritten with exponents. And here's kind of the reason why they cancel out. So square root of x is the same thing as x to the 1/2 power. Also recall that if you had power to power of something, so let's say I had b raised to the m power, and then I was raising that to the nth power. Remember, the rule was to multiply your exponents. And so basically the reasoning behind that the square root of x quantity squared equals x, it's because this is really x to the 1/2 power, right? Square that. This is x to the 1/2 times 2 power, which is x to the first. So that's the whole purpose of, finding the conjugate so that when we distribute, the square root would go away. So this would just give us x in the numerator minus, and 6 squared is 36. So we have x minus 36 all over the square root of x plus 6. Did that answer your question? Did that clarify what you were asking? I know sometimes it takes a moment to get into to find the unmute. So notice here, once we multiply through by that conjugate, we now again have like factors in the numerator denominator. So we have x minus 36 in the numerator, and we have x minus 36 in the denominator. And so those factors are going to cancel. And we're left with a 1 in the numerator. So the limit is x is approaching 36 of 1 all over square root of x plus 6. So now when we go do direct substitution, we're not getting 0 over 0 anymore. So going in, direct substitution, we have 1 all over the square root of 36 plus 6. Or 1 over square root of 36 is 6 plus 6 in the denominator, so 1 over 12. So questions about that one before I stop the video? Okay, so let's look at a piecewise function. So we're called piecewise functions are functions that have different equations, and the equations depend on the domain for that. So for instance, let's say we have let f of x equals, and then we have this huge curly bracket, and our first equation is x minus 1. And this is if x is less than 3. And then we have the second equation is just the constant 2. And we use that equation if x is between 3. So 3 is less than or equal to x, which is less than or equal to 5. So x is between and including 3 and 5. And then the second equation is x plus, I'm sorry, it's not second, third, x plus 3. And this is if x is greater than 5. Okay, so let's just kind of review this a little bit. So it really depends on what value you're given for x, depends on what equation you're going to use. So for instance, if I said, let's find f of 1. So I'd have to go in here. So x is equal to 1 here. I want to figure out what y is. Well, you have to look at x equals 1. Does it fall in here that 1 is less than 3? So 1 is less than 3. 1 isn't between 3 and 5, and 1 isn't bigger than 5. And so that tells me, includes me in, to find f of 1, I need to use this first equation. And so we would have f of 1 is equal to, I see an x, I'm going to replace it with 1, so parentheses, and then minus 1. So f of 1 in this case is 0. So I can technically draw a graph. So I know anything where x is less than 3 is this piece x minus 1. And so we actually found one point, 1, 0. So I have a point here. It's actually in the form of y equals mx plus b. So I know my slope is 1. Looking at this, I know what my y-intercept is. It's negative 1. I can plug in 2 because 2 is still less than 3. If I did that, if I plug in 2, I get back the number 2 minus 1, so 1. And then if I plug in 3, the problem is this is strictly less than 3. When you're graphing this though, we want to see what's happening at the end values of our inequality. And if it's not included, we put an open circle there. So if I plugged in 3 into this first equation, 3 minus 1 is 2. So I know at 3, I have 2, but it's an open circle. Okay, so looking at the second equation, The second equation is just y equals 2, or f of x equals 2. And this is numbers between x equals 3 and x equals 5. So 3, let's go up to 5, 4, 5. So at 3, though, we have the equal to part in that inequality. So when x is 3, y is 2. So use 3, 2, and it's a solid circle. It just happens to be where this open circle is, so now I'm going to close it. 4, I get 2. At 4.5, I get 2. It's a horizontal line. And then at 5, it's also included in the inequality, so it's going to be solid. And then the last piece, last equation, which says x plus 3. So this would be the equation y equals x plus 3. Again, this is a line. It's in the form of y equals mx plus b. So I know what my slope is. It's a number in front of x, which is 1. And my b value is 3. The only thing is that this graph doesn't actually hit the y-axis because it has to be bigger than 5. So let's see what happens actually when we put in 5, even though it isn't a point for this third equation. So if I put in 5, though, I get 5 plus 3, that's 8. So at 5, I have 8. It's an open circle. And then if I plug in 6, I get 9. And erase this stuff. And so I just know it's a line, it's increasing. And so it goes up like this. So it's helpful if you can graph these piecewise functions and know what's going on and what the notation is, f of a number. Really quickly, let's look at one limit, or a couple of them. What if it says, look at the limit here as x is approaching 3. So 3 is actually where it changes equations. So remember, for a limit that exists, both the left-hand side and the right-hand side have to exist. So let's look at the limit as x approaches 3 on the left of f of x. Well, I have the graph here, so I could just kind of look at it. As I'm getting closer and closer to x equals 3, my y value that I'm hitting is 2, or getting closer and closer to. So this would equal 2. If I look at the limit as x is approaching 3 on the right, so coming in on the right-hand side, my y value is also approaching 2. So that equation was x minus 1, and this equation here was just 2. Recall, if the limits are the same on the left and the right, then the limit exists and it goes to that number. So the limit as x approaches 3 of f of x is 2. We'd have to be careful. Notice at 5, there's a jump in the graph. I can tell that my limit as x approaches 5 is not going to exist because my limit as x is approaching 5 on the left-hand side is going to 2, where the limit as x is approaching 5 on the right-hand side is going to that, even though it doesn't touch it there, it's getting closer and closer to 8. So maybe just write that really quick. So the limit as x approaches 5 on the left, that uses my equation. I'm just going to write that equation 2, which equals 2. The limit as x approaches 5 on the right That equation I use is x plus 3. And this equals 8. So the limit as x approaches 5 of f of x does not exist. And again, it's because the left and the right-hand side limits are not the same. Okay. So unfortunately, we haven't looked at limits as x is going to infinity or negative infinity. And that is still a piece of this section. I do want you guys to get in and do as much as you can in this homework. If you haven't already done so, if you haven't finished it already. But get in, do as much as you can of the topics that we've covered, and then I will finish this up next week on 3.1. So 3.1, I'm going to move again. So technically, no My Math Lab homework due on Tuesday, but that kind of scares me. So, but make sure you get in there and do work. Other thing I need to mention really quick. Let me stop this and do it on a new video.